All right, welcome back to Math with Miss Lastly. Okay, that's not fun. I did it in the last video. It wasn't cool then. I just did it again now. It's the same night, guys. I don't know if you can tell, but I'm in my same outfit because it's the same night. So I'm actually just trying to knock out all of these Unit 2 videos in one day. Let's see if I can do it without going super crazy. Anyways, today's video is on imaginary number irrational. What the heck? Hold up. Okay, I fixed it. Imaginary and irrational zeros. All right, so this is kind of a tough concept and it's probably going to be quite a long video only because I want to make sure you guys are kind of okay going through all the steps. You're not really learning any new techniques today. We're still going to be using synthetic division like we did in our last video, but instead of working with whole numbers and fractions, we're going to be working with imaginary numbers and irrational numbers, which are like the square root of 3. That's an irrational number. So without any further ado, let's get into it. Okay, so just a really quick thing with imaginary numbers. I wanted to make sure you guys knew when imaginary numbers multiply together, what happens. Okay, so just a recap for imaginary numbers. So if you have the square root of -1, that's I. Okay, well, if you have I squared, that actually simplifies to -1. All right, I cubed, that's going to be negative square root of -1. And then I to the 4th is +1. So it's -1 times -1, which is +1. All right, so those are your I kind of rules. All right, so I'll just put them all on like the same side. I don't know why I wrote that one over there. It felt right in the moment. All right, so this is what we call the I cycle, because once you hit 4, it then kind of goes back up to I and the pattern repeats. All right, now we don't need to know that much for this, but we do need to make sure that we understand for the most part, the important one is I squared equals -1. So I have a practice one that I want to go through with you guys. So I have 2i minus 3 times 4i plus 1. Now, cool thing, your calculator actually can handle doing imaginary numbers and it will give you the answer. So I'm just going to pull up this calculator really quick. We're going to do this by hand, but I'm also going to show you how to do it on the calculator. So while the calculator is pulling up, we'll do this by hand really quick. So I would recommend using the box method to multiply these together. All right, so that's what I'm going to do. So I'm just going to make my little box. Bloop, 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 bloop. 2i minus 3 and then 4i plus 1. And then we just multiply. So 2i times 4i is 8i squared. We're going to simplify later. All right, -3 times 4i is -12i. 2i times 1 is 2i, and then -3 times 1 is -3. So when we bring this out, we have 8i squared minus 10i minus 3, and we can simplify because I squared is equivalent to -1. So this becomes 8 times -1, which is -8, minus 10 minus 10i minus 3. And then we can combine our like terms. So we have a -8 and a -3. So this equals -11 minus 10i. So that was by hand. It kind of took a while. All right, so I am going to show you the faster way to do this because why not? We have calculators. Why shouldn't we use them? Oh, nope, stop doing that. All right, so let me just go ahead and move the calculator. Open up right here. All right, we should be able to see you, calculator, with, oh, there you are. All right, cool. Okay, so I'm gonna just kind of make this smush down a little bit. Okay, and I have this graphing thing over here from something else, so we're just gonna clear that out. So go to y equals Actually, it doesn't really matter. Second, quit. Here we are. Okay, so the first thing that you need to do in order to be able to do this on your calculator is smush this a little bit more because it's too big. There we go. Now we fit better. All right, so you need to go to mode. So you need to hit the mode button, and what you're looking for is the A plus BI feature to be highlighted. So it's kind of small, so I'm gonna like look at this screen really quick because I can't see. Okay, I found it. All right, so on this calculator, I'm going to use the arrows to scroll down. All right, and you see where it says real? See where it says real right there? Now your calculator might look a little bit different, but you should see something that says real and then A plus BI. If I scroll over sideways, I want to highlight that A plus BI. So I'm gonna hit enter on that. All right, so now I've put my calculator into imaginary mode. Now it's gonna let me actually do math with imaginary numbers. All right, so now that I've changed it to A plus BI, I'm gonna go ahead and do second quit to get out of there. And now I'm gonna just plug in the exact same thing that I was multiplying over here using my calculator. So I'm gonna do parentheses, and then it's 2. Now the I button is this decimal point. All right, so I don't know if you can see it, but right here I have that I, imaginary I, so second, and then the decimal point, and then -3, close parentheses, open parentheses, 4, second, decimal, which is my I button. Sorry, I'm looking over on this screen. It's just that's where the calculator is. Just bear with me. So I have 4i and then a +1, close parentheses, and now when I hit enter, it does the math for me so I don't have to do it by hand. All right, so it gives me -11 minus 10i, which is exactly what I got when I did do it by hand. So that is a really awesome feature that your calculator should have. Generally, any type of calculator should have it. I even think that this one, non-graphing one, has it. Let me just triple check before I say things that are false. Nope, that was false. This one doesn't have it. But some of them do, so it doesn't necessarily have to be a non-graphing or a graphing calculator. Some of the non-graphing ones will work also. It just so happens that this one does not. But that's okay. I don't need to use it. All right, so anyways, that's a really good feature for what we're about to do. And I'm actually going to use the calculator when I do some of these problems because I'm lazy and I don't like to do them by hand. So just saying. Okay. I'm going to minimize this really quick. I'll pull it up later, but we have some more stuff to kind of get to before we actually use the calculator for math. Okay, so next we need to talk about rules for I and irrational numbers. All right, so if you have a 0 of your function, so like last night on your homework, you were given like one of the zeros or one or two of the zeros, and you had to find the remaining ones. Well, if you have an imaginary or irrational 0, those come in pairs. All right, so I know that's kind of funky, but think about it this way. In order to get an I, you had to have a square root. In order to square root something, you were probably using quadratic formula, which has a plus or minus inside of it. So anytime you get an I, it means there was a square root. So that means you had to do a plus or minus. So when you're dealing with your imaginary, same thing goes with irrational. If you have a square root in your problem, the only way you got that square root was either by using the quadratic formula or taking the square root of both sides of an equation. Anytime those two things happen, you will always have a plus or minus out front of that square root. So here's the main rule that we want to talk about. All right. So if you're given oh my gosh, okay. All right, I will be right back. My dog saw a squirrel, so I need to go handle that real fast. You guys aren't gonna notice, but I'm just gonna pause it. I'll be right back. Okay, I'm back. They just wanted to go chase a squirrel outside. Dogs are so fun. All right, so anyways, as I was saying, if you're given one imaginary 0 or irrational, doesn't matter. Zero. There is also a second one that you know. All right, so what that means is, say the problem gave me, say it said one of my zeros is x equals the square root of 3. Well, if you have the square root of 3, you also have negative square root of 3. Right? Because in order to get that 3, you had to square root something. Anytime you're square rooting something, you always have a plus or minus. So if the problem gives you the positive version of the square root, then just know you also have the negative version of that square root. All right, same thing goes with I. Say the problem gave you x equals 2 plus 3i. Well, guess what? You also have the negative version of that I, right? So you also have x equals 2 minus 3i, right? Because remember, it was plus or minus some negative square root, right? Would have been plus or minus negative 9, right? So you have 2 plus the square root of negative 9, which is 3i, and you have 2 minus the square root of negative 9, which is 2 minus 3i. All right, so irrational and imaginary numbers come in pairs. That's the main takeaway from this. So now we're going to do some problems dealing with dividing. So that rule isn't really the hard part. What's hard is that now we're going to do synthetic division with these kind of strange, gross numbers in our corner box. All right. So the instructions say, using the given 0, find the remaining zeros and write f of x in factored form. Of course, all about factored form. All right, so we're going to start with an irrational number. So we're going to start with the square root of 5. So we make our corner box. I'm putting in the square root of 5. And now I'm going to line up my coefficients. Now, I am missing a couple of them. So remember, I had to put a 0 in as a placeholder. So 1, then I'm missing x cubed, 4 for x squared, 0 for my x, and then a minus 45. Now, this minus 45, this is still my remainder column. So even though I'm dealing with the square root of 5, I should still get a 0 as my remainder. All right, here's what it looks like. So I bring down my 1. Now I multiply. Square root of 5 times 1 is the square root of 5. I bring it down. I add. 0 plus root 5 is root 5. Now I multiply. Square root of 5 times square root of 5 is 5. So that's going to go underneath the 4. Now I add. 4 plus 5 is 9. All right. Now I multiply. Square root of 5 times 9 is 9 square root of 5. I add down 9 root 5. Now I multiply. Square root of 5 times 9 square root of 5 becomes 9 times 5, which is positive 45. Add down, I get my remainder of 0, so I've done it correctly. All right, so just be careful when you are multiplying. All right, so square root of 5 times the square root of 5 is 5. And then when you're adding, that one's not usually a problem. All right, so just kind of be careful when you're doing your multiplication. Okay, so I got my remainder of 0. I can kind of move on. Now, instead of going through the problem and putting our x's back in at this point, we don't really want to do that, right? Because if I do put the x's back in, I'm left with some pretty ugly coefficients. So before I put my x's in, I'm actually going to divide out by my other 0 that I know. Because if I'm given x equals 5 as a 0, I also have x equals negative square root of 5 as one of my zeros. All right, so what I'm going to do before I put my x's in, I'm going to go through and I'm just going to take these coefficients that I have and I'm going to divide out by negative square root of 5. So I'm not even going to rewrite this. I'm going to leave it just like this and do negative square root of 5. All right, so these are my coefficients. I'm not, like I said, I'm not doing anything else with them. I'm just going to divide out again by negative root 5. This is my new remainder column. I should get a remainder of 0. All right, and I start by bringing down my 1. All right, now I multiply. Negative square root of 5 times 1 is negative square root of 5. I add down, I get 0. Next, I have negative root 5 times 0, that's 0. I add down, gives me 9. Now I multiply. 9 times negative square root of 5 is negative 9 root 5. I add down, guess what? I get 0. All right, so now I'm back to having nice, pretty coefficients. All right, unlike originally when I had these gross ones, which I don't want to put variables back in if I have gross coefficients. Now, making sure I figure out which variables to plug back in correctly. All right, so if you look at the problem, right, we divided once by square root of 5. That took x to the 4th and gave us an x cubed. So if we were to go through and put our variables back in, that would have been x cubed, that would have been x squared, that would have been x, and that would have 9 root 5 would have been my constant. But I didn't put them in at that stage. I just divided out again by another 0. So what that's going to do is it's going to bring it down one more exponent. So this is going to be x squared. This would have been x to the 1st. And then the 9 is my constant. All right, so what I have here is x squared plus 9 and x plus square root of 5, x minus square root 5. Okay, now, when I look at this, something doesn't look right. When you factor, do you get square roots in your factors? No, you don't. You don't get square roots. So what we have to do is we do need to multiply these two parentheses together to get rid of the square roots. All right. Now there is another way to do this. All right. So instead of doing it using this technique, you can use a different technique, but multiplying out is kind of easier. So you have that option. I'm going to show you both ways. So multiply these two parentheses together will get rid of the square root of 5. All right, so that's what I'm going to do first. I'm just going to multiply. So x squared plus 9 stays the same. All right, and then I multiply. This is going to give me x squared minus x root 5 plus x root 5 minus root 5 times root 5 is 5. Those middle terms go away. All right, so I'm left with x squared plus 9 and x squared minus 5. All right, so that's one way to get rid of those square roots inside your factors, because you are not allowed to leave square roots inside your factors. You have to get rid of them. The other way you can do this is by making your equation. So you had, when you have x equals root 5 and x equals negative root 5, what you can do is kind of work backwards. So you can say, all right, well, this was x equals plus or minus the square root of 5. And then what you want to do is kind of the reverse. So you want to undo everything. So you want to undo square rooting. So undoing a square root means you squared both sides. So that gives you x squared equals root 5. When you square a plus or minus, it becomes a plus. All right, and then you move the 5 over. So x squared minus 5 equals 0, which is what you got right here. All right, so you can either take the two factors that have the square root in them and then multiply them together and it will make the square root go away, or you can take the equation that was the 0 and you can kind of undo everything to get it back to equaling 0. So you can square both sides, get rid of the square root, and then subtract 5 on both sides. Both of those options are going to give you that nice factor form that we actually want. We don't want square roots of 5 in our answers. All right, so this is now factored form. All right, because x squared plus 9 doesn't factor anymore, right? X squared plus 9 is close to difference of squares, but it's a plus, so it's not going to be difference of squares. All right, so we have put this into factored form. The last thing the problem wanted us to do was to find the remaining zeros. So we have 2 zeros. Based on the given problem, we know that we should have a total of 4 zeros. All right, so the zeros that we do have, we have root 5, we have negative root 5. All right, now we're going to take the x squared plus 9, equal it to 0, and that's going to give us our remaining zeros that we're missing. So x squared plus 9 equals 0, x squared equals negative 9, x equals plus or minus the square root of negative 9, so x equals plus or minus 3i. All right, so that's all 4 of my zeros. All right, so none of them ended up being nice numbers. That's okay, doesn't matter. I don't have to do anything with them. I just have to find them. All right, so those are my 4 zeros. I am now done with the problem. So I have my factored form, I have my zeros, I'm good to go to the next problem. All right, now that was doing it with an irrational 0. Now what we're going to do is we're going to do one that has an imaginary 0. All right, so problem number 2. Given that we have this 0, x equals negative 3i, now we also know that we have x equals positive 3i. All right, because remember, imaginary numbers and irrational numbers come in pairs. They're just negatives of each other. One will be plus, one will be a minus. Okay, just like with our irrational square root of 5, we're going to take our imaginary zeros and we're going to put them in the corner box, and then we're going to line up our coefficients. So here we go. It doesn't matter which one you start with. I'll start with the negative one just because that was the given one, but it doesn't matter. All right, so now I'm going to line them up. I got 1, and then 2, and then negative 39, and then 18, and then negative 432. Wow, that's a big one. All right, this is my remainder column. Remember, we should end up with 0, so hopefully that's where we end up, right? Okay, so bring down my 1, and now I'm going to multiply. Negative 3i times 1 is negative 3i. Now this might be where you would want to use your calculator. So here's my calculator. It kind of sucks that it's like right there, but it is what it is, I guess, at this point. I guess I can move this over a little bit and then put my calculator up. But now I lost my calculator. Where did you go? There you are. Okay. That kind of helps, but not really. All right, so if you want to use your calculator, feel free. So this is 2 plus negative 3i, and that's just 2 minus 3i, which you probably could already figure out. All right, and now what I'm going to do is I'm going to multiply by my corner number, which is negative 3i. So negative 3i times, and I'm just going to do second answer because that's going to it's going to be 2 minus 3i in there. So hit enter, and that gives me negative 9 minus 6i. So negative 9 minus 6i. All right, and now I'm going to add negative 39. And that gives me negative 48 minus 6i. Again, you could do this by hand, but like, why? All right, so negative 3i times second answer, which is just negative 48 minus 6i, enter. All right, I have negative 18 plus 144i. I'm running out of some space here. That's okay. All right, now I'm going to add 18, so plus 18. So I have 144i, and now I'm going to multiply that by negative 3i. Right? This is just bring that down, 144i. Now I'm going to multiply, hit enter, and I get 432. Guess what? That makes 0. Yay! I did it. Okay, so that was super gross, but that's what calculators are for. If you did that by hand, kudos to you. You're a better person than I am. I did not want to do it by hand. Okay, so just like with the irrational number, remember, since we divided out by 1, 0, our exponent now drops down by 1. So if we were going to go put our variables back in, this would be x cubed, this would be x squared, this would be x to the first, and 144i would be my constant. Now, I am not going to put the variables back in because this is disgusting. I do not want to have a standard form equation that has i's in it. So the next thing I'm going to do is just before I put the variables back in, I'm going to divide out by 3i. And this one should be really nice. A lot of things are going to end up canceling out. So I'm going to go to my corner box without even moving my coefficients. I'm just going to divide again with positive 3i. All right, this is my remainder column. I should end up with 0 right there. Now, I really don't even need my calculator. Like you're going to see, everything kind of cancels itself out, so it actually works really well. All right, so bring down my 1. All right, 3i times 1 is just 3i. And then look, we have 2 minus 3i plus 3i. The 3i's cancel, and I'm left with just 2. All right, now I multiply again. 3i times 2 is 6i. Put it underneath there. Guess what? Those are going to cancel. So I'm left with negative 48. All right, now I have 3i times negative 48. If you don't know what that is, you can definitely use your calculator, but I'm going to go ahead and say that it equals negative 144i because that's what I needed it to be. I'm pretty sure it does, but you can always double check it on your calculator. But anyways, I'm going to say it does, and that gives me my 0 remainder. All right, so now I can go through, and since I divided out by another 0, I can take that x cubed and drop it down again to x squared. This would then be x to the first, and then the 48 would be my constant. So at this point, factored form looks like this. So y equals, I have x plus 3i, x minus 3i, and x squared plus 2x minus 48. Okay, just like with our irrational zeros, we cannot have, irrational factors, we cannot have i's as in our factors. So we need to get rid of them. So again, you have two options. You can multiply these together. When you do that, it's going to get rid of the imaginary number, or you can take your imaginary zeros. So we had x equals plus or minus 3i, and you can undo this to get it back to equaling 0. It doesn't matter which technique that you choose. Both of them are going to work 100% correctly and get you your factors that don't have imaginary numbers anymore. What I'm going to do is doing the reverse technique because I like it a little bit better. So to do that, I'm just going to square both sides. All right, this becomes x squared equals, now it's 9, and then I squared is negative 1. So this is actually negative 9. So x squared equals negative 9. Now I'm going to add 9 to both sides. All right, so that's my actual factor that I'm going to put in my problem. So this becomes y equals x squared plus 9. Oh no, I have ice cream. My spoon fell over. Okay. I was really hungry earlier, so I got a snack. It's melting a little bit, but that's okay. I'll eat it in a second. We're almost done. Okay. So we have x squared plus 9, and then we have x squared plus 2x minus 48. Okay. Now, I know that the x squared plus 9 doesn't factor anymore because if I were to try and do it, I would have imaginary numbers, and I don't want that. So x squared plus 9 is fine. But I need to double check and see if that x squared plus 2x minus 48 factors. I think it might. So I need two numbers that multiply to negative 48 and add to positive 2. So 48 is 6 times 8. And if the 6 is negative, then I can get a 2 in the middle. So this actually does factor. So that's just normal quadratic factoring though. I didn't have to use synthetic division. I just factored the x squared plus 2x minus 48, and it's going to give me x plus 8 and then x minus 6. You could go through and do the box if you want, but I just kind of did that one in my head. Okay, so now this is complete factored form. This is factored form. All right. So the last piece of this question was to find all of the zeros. So I have x equals 3i, x equals negative 3i. All right. Now for my last two, x plus 8 and x minus 6, I'm going to get x equals negative 8 and x equals positive 6. So I have 4 factors, and just to double check, make sure that's how many I was supposed to have, and it is. This is a degree of 4, so I should have 4 total zeros of my function, and I found 4. So I did it right. Okay, so that is it for this part of our notes. Now there is one other problem that we don't need to go over it because it's not anything new. It's still just imaginary numbers, but it is kind of a tough one. So I'm going to do it in another video. So if you would like to see me do problem number 3, I'm going to make it into its own separate video. It works exactly the same as problem number 2 with imaginary numbers, but some people kind of think this one is a little bit harder. So I'll do it in a separate video, but I'm kind of going to cut this one off. We are at 32 minutes right now. So yeah, so I hope you guys found this video helpful. If not, come to office hours or whatever. You guys get the drill. I will see you in the next one. Bye.